Alright friends and neighbors, time now for another networking video. Today we're going to talk about tables. But we have talked about tables in the past. What I'm going to do today is add on the association table, which is a wireless thing. And who knows, maybe this summer and the weeks coming up I'll do a wireless series. Okay, so tables. So the first thing that we ought to realize is that we have lots and lots of tables out there, but there are basically 6 that we really need to pay attention to. At least until we get into advanced configurations and stuff like that. And that is the host routing table, the host ARP table, the switch source address table or MAC address table, the router routing table, the router ARP table, and now the access point association table. So that's really what we're going to add today. And just as a quick glance at the topology that we're going to go through, let's take a look at Packet Tracer. So here is our basic topology, and what we're going to do is we're going to go from the 15 net over here to the 20 net, and I suppose I can add that. We'll do 192.168.15.0/24, and that's on this side of the router. And then on the other side of the router we've got 192.168.20.0/24. And you know, we can see that there's a difference between this topology and a lot of the others that we've done here on the channel, and that is we've got wireless devices over here. Now we'll see that the wireless devices in Packet Tracer don't always give us, you know, exactly what we want to see. So we'll kludge that a little bit, but we'll be able to see a lot of the connectivity. So let's walk through the processing as we go, and we'll start on the host. Now first up we have the host routing table, and that's the top one that we see here. And Packet Tracer doesn't give us a lot of visibility into the host routing table, but this is kind of what we would see if we were on that set of left hosts, right? We have the basic host routing table entries that we've come to know and love. We've got limited broadcast, directed broadcast, multicast, the IP address of the host itself, the network, loopback, and then of course the default gateway, which in this case is 15.254, which is what we have in the topology. And the host ARP table. Now when you're processing tables, the very first thing that you do always is process this host routing table. And then if you need to, you process the, well, let me say that differently. If you don't have an entry in the ARP table, then you have to ARP. If you do have an entry in the ARP table, then you don't have to ARP. You just pull the MAC address from the ARP table. And so we'll take a look at that here on the topology here in a minute. The next table that we will run into in the topology, let's take a quick look, would be on the switch. And again, as we go through our example, I'll show you all the tables, at least the ones that we can see in Packet Tracer. But on the switch, we would have the source address table. So every device that you come along has a table of some kind, sometimes more than one table, that dictate how packets or frames are going to be forwarded. And I said packets or frames because sometimes they're forwarded based on the layer 2 information, MAC addresses, or they're forwarded based on the layer 3 information, IP addresses. And you can see next in line we have the router. Now the router is significant because it has a router routing table and a router ARP table. Just for fun, I put it in the slides. I'll pull the router routing table and the router ARP table here, and we'll take a look at those here too. So here is the switch source address table before we get to the router. And I'll just remind you that we know that every table is a mapping between two things. So the host routing table is a mapping between network destination and the interface that you're going to use. And the host ARP table is a mapping between the IP address and the MAC address associated with that IP address. The switch source address table is a mapping between a MAC address and the port to which that MAC address is connected. But if you watch the recent videos, you also know that there's this VLAN column. And switches have a very particular way of forwarding things based on the VLAN. So that's important. If you're a little bit lost there, go watch the video on all the VLANs and trunks that we just did. So this is what the switch is looking at. When we get to the router, of course, we have the router routing table. Now in this particular case, we can see that the router is directly connected to the 15 and the 20 net, and then the /32 entries, those are for the router IP addresses themselves. Now a router is just another kind of node on the network. It has an IP address, and so it obeys the same rules as any other IP addressed host, like the computers, or your printers, or your game consoles, or whatever. It just has a very special function, forwarding IP packets. But it also has this ARP table that provides the mapping between the IP addresses and the MAC addresses. And the reason it does that is because it needs to accept frames in on one side and then rebuild frames on the other side, going out its other interface. So that's why a router needs an ARP table. It needs to know how to build a frame to the next destination. And of course, in our topology, we know that there's another switch, and so there would be another one of these tables in the topology. And when finally we got to the destination, there would be other host routing tables and other host ARP tables so that we could get the traffic back the other way. So the one that's missing here is the show.11 associations, the access points association table. So when we do a command like this, we're looking at what the access point knows, or how the access point makes forwarding decisions. Now, access points are sometimes called wireless hubs, and that's not exactly accurate. Why? Because like a switch, the access point is very aware of MAC addresses. And so what happens as a part of the process of connecting to a wireless network, what hosts do is they go through a process of probing. It can be active, it can be passive, but eventually the hosts find the network to which they'd like to connect based on the SSID. When you connect to a network SSID, you're actually connecting to a particular access point, and you go through a three-step process. You do that scanning, then you do the authentication, and then you do association. Once you are associated, you are entering into, or you are entered into, the access points association table. And so your MAC address appears in the association table. Now, a lot of times the IP address, it depends on the vendor, right? The IP address, the type of device appears. But really the important thing is that the interface to which you are connected, the SSID, and the MAC address. And this is how the access point knows that it is supposed to handle traffic for this particular node. And so a very important table is the access points association table. So let's take a quick look at our topology. Now first of all, let me show you that this actually works, right? So I did a bunch of tests already, but we'll go to 15.2. So I'm on 15.1. Let's go to 15.2. And we can see that works. Let's go to 254. Okay. So if I was going to label this completely, I might say something like this. This is 192.168, 15.254. Over here, we've got 192.168, 20.254. And then this device all the way over here, 192.168.20.1. So the two different sides of the network. So again, on our host, we'll just work our way over there. We'll say we want to get to 20.254. That's the other router interface. And then we'll try to get all the way to 20.1. So that looks like it works. Okay, excellent. Well, we already know that when I'm on this particular host, I process my host routing table first. And Packet Tracer doesn't do a really good job of showing this to us, but we took a look at a host routing table earlier on. It looks like this. So there's our host routing table. And in this case, because we're going across to 20.1, this is the entry that would match. And again, if you're a little lost there, just take a look at the host routing video that I did earlier. Now, at the same time, we're going to process this host ARP table. Now, why do we do that? Well, eventually you're going to find out which interface you need to use, and you'll learn whether or not you can communicate directly with the destination, meaning that it's on your network, or you need the default gateway. And so you would be looking for one of those addresses here. This is just an example, but we can take a look at the host ARP table in Packet Tracer. So we take a look at this node, we can do ARP-A, and here is our host ARP table. Notice that nobody on the 20net is part of this ARP table, and that's because you never ARP for somebody that's not on your network. And so the only entries that appear in an ARP table typically will be those on your network. And so here we have the default gateway and another host. All right. Well, that's the host routing table and the host ARP table. When the traffic gets up to the switch, of course, we process the switch MAC address table. And that's this here. Well, let's take a quick look at the MAC address of this particular host. It ends in 1873. So when we look at the MAC address table or the source address table on the switch, we can say that that particular MAC address is connected to port 1. When the switch gets frames, the switch makes forwarding decisions based on the MAC address table. That's everything that the switch knows at this point, mostly because the switch doesn't have an IP address. We can also see that by default, all of these ports are connected to VLAN 1, and that's standard for Cisco switches. Okay, well, let's take a quick look at the router tables. We can do a show run, or we can do a show IP route on the routing tables, and we can see again that we are directly connected to the 15 and the 20 net. So this router says, cool, I see where you want to go. I know where the 20 net is, but now what does the router do? Well, the router has to connect to this wireless device over here. In order to do that, it needs to build an Ethernet frame that goes down here and heads out. Well, how does it do that? And the answer is that the router has an ARP table too. Okay, and we can see that 20.1 is connected here. Now, the IP address and the MAC address, this is the mapping that an ARP table provides for us. So again, tables provide a mapping of one kind of information to another, and it's not duplicated across the tables. Okay, so let's say that this node had pinged this node over here like it just did, right? We just did that, right? So that's the, well, we'll do it one more time. There we go. So we've talked about the host routing table and the host ARP table. We got it out here to the switch source address table. We've gotten it up here to the router routing tables and the router ARP tables. And then we eventually go down here to the switch source address table again. Well, let's see. Again, these packet tracer wireless devices don't have a lot of information in them, but we can see that we've got a MAC address associated with it, so we can take a look where that might appear. And so 4D85, and so we take a look at this switch source address table or MAC address table. And there is 4D85 right there. All right. So that tells us that it gets passed down this direction because this is port 23. And if we took a look at that, right, it was connected to port 23. Okay. So now it gets out here, it heads down to the access point, and the access point says, okay, well, where do I need to send this? Well, we know now that there's this access points association table. So we'll take a quick look at that again. Now this access points association table is just an example. You can see it's not the same network or anything like that, but it is an example of what you would see in an association table. And the key idea here is that there's a MAC address out there. So if we take a look at our topology here again, what I'm going to show you is that there are two access points out there. And what we're trying to figure out is how does an access point know that it's supposed to generate traffic or it's supposed to handle traffic for this particular node. We can see that I've configured two access points. And if we look at the basic configuration for the access points, we can see that I've configured an SSID or service set identifier, and they're both called Calvin. And so we go over here, same thing, right? They're both Calvin. So that means there's two access points out here that have the same SSID. Now in a perfect world, what you would do is configure them on different channels. And maybe if you were doing security, you would configure them with, WPA or WEP or something like that. They would need the same security tokens because it is just a layer 2 network. But you can see that this particular host has connected to this particular access point down here. Well, what's the big deal? Well, let's imagine that a broadcast frame goes out this way, or the switch isn't sure where the destination is, or what have you. And so the traffic might go down both of the links to the access point. Well, which one handles the traffic? And the answer is that this access point would. Why? Because the MAC address of this node is in its association table. Now, you might be saying, well, geez, clearly that's the way that it ought to go because, well, we can see we've got this wireless connection. But it's the same SSID, right? These two are part of the same wireless network because they have the same SSID. In fact, if I did something like this, whoops, if I deleted this access point, watch what happens with the node. Because they're the same SSID, this node jumps right over here to this other access point. So that would lead me to believe that maybe everybody blasts this traffic out everywhere, and that's not the way that it works. What happens is that only the access point with the MAC address of the host in the association table handles that particular traffic. All right, so there we go. We've added our sixth table to this collection of basic tables that we have, and it's really important, especially today. I mean, wireless is everywhere. It's really hard to run a network today without knowing something about wireless, and so I just thought that today we would add that particular table to our collection of tables that we know about. Tables, and more tables. Now, so those are our six basic kinds, right? We've got a couple of routing tables, a couple of ARP tables, a switch source address table, and then the access points association table. And we kind of saw that the access points association table and the switch source address table are very similar. And that makes sense. Both of them are forwarding traffic based on MAC addresses. In fact, you can even push VLANs out to your wireless SSIDs, which sort of makes them even closer together. But there is a difference in the processing, and that is that we care less about a particular port, right, and more about an SSID in that particular case. All right, if you understand these six basic tables, right, in the forwarding and the mapping that they use, well, you're in pretty good shape. There are lots and lots of other tables out there. Network address translation tables, access control list tables, firewall tables, label tables if you're doing MPLS, so on and so forth. But these are the foundational six that we need to really understand how traffic is forwarded. Thanks for watching. Thanks for listening. Like and subscribe if I helped. And, you know, this is networking. You can do this, and may those packets always reach their destinations.